Arrays are used in almost all programming languages, and they're very useful at what they do. Now, most new programmers find it very difficult to understand arrays, and the reason for this is that while arrays are often explained well, it's not often explained why they're needed. So in this introductory lesson, I'm going to go through why you would need to use an array. So you can see on the left hand side here we have student marks. We have the marks as 6 and student as 1, and this code will print out the mark. So mark is 6. So essentially it reads the value, stores it in a variable, and then prints out that value. So let's imagine we're going to add a second student. So we'll just add the student marks first. So we have 2 students now, and the second mark is 9. So to add this student in our code, we basically have to double up on the code. So we need to add a second variable, we need to add a second assignment, and we need to add a second print statement. And of course it all works very well, and when we run the code we'll get the value that we require. So we can see the marks of 6 and 9. Now imagine we get a new requirement, and this time our requirement is to print the values for 10 students. So we'll just add some random marks here for the students. Now if we go back to our code and we want to adjust our code to work for this particular scenario, we'll need to have 10 times the original lines of code. In other words, we'll need 10 declarations, 10 assignments and 10 print statements, meaning that we have 30 lines of code. Now imagine we had 1,000 students, well then we'd need 3,000 lines of code, and 1,000 data items is not that big. So how would we deal with this? Well, we use an array. So let's have a look at some code for the array. Now again, don't worry about this code for the moment. We'll be breaking down what it does in the next few lessons. In this code, we use an array of students that is 1 to 10. We then run through this array and add the value to each one, and then at the end we run through this array and print out the values. And when we run it, you'll see that it prints out all the values. And yet we only used 8 lines of code, and that includes declarations. Now, if we were to increase from 10 students to 100 students, say for example, we only need to make the change in 2 places. And in fact, we could really reduce this to 1. So by changing the 10 to 100, our code will now work for 100 students. If we didn't use arrays, we'd need 100 lines for declaration, 100 to read in the variable, and 100 to print. And you can imagine this is not feasible. So now that we've seen why we use arrays, in the next few lessons we'll see how to use them. In this lesson, we're going to look at declaring arrays. Now the 3 student variables we have here, we're going to replace these variables with an array. So how we declare an array is very similar to declaring a normal variable. The difference is we have parentheses afterwards, and these parentheses specify the range. So here we say 0 to 2, and what this means is that we have slots starting at 0 and finishing at 2. In other words, 3 slots. Now it's common practice in programming to start an array at a 0 slot rather than 1. So let's look in our locals window. You can see here that our students array has been created and that it has 3 slots, and they're students 0, students 1 and students 2. Now the one problem with declaring an array in this way is that we're stuck with the size of it. So in other words, each time we run, we have an array of size 3. Now a lot of the time when you're writing code, you'll be dealing with data items which might be dynamic in nature. So in other words, you might read students from a number of sheets, and these sheets may have a different student number. So how we declare a dynamic array is that we just use parentheses, but we don't tell it in advance the size. And instead then, when we're ready with the size, we use readDim. Now in the example here, both of these will do the same thing. So we'll run it again and we'll get the exact same variables. So yeah, we just need to change the name because obviously we're going to have different names for the arrays. So let's run it on, and you can see the two arrays are exactly the same. But the benefit of the dynamic array is that we can change the size at runtime. So let's look at an example of this. So imagine here we have the student count as being 3. So if we were to read lots of different sheets, and all the sheets have different numbers of arrays, well then we can use a dynamic array, because each time we read the sheet, we read the student count and create an array of that size. With the static array, it's much more difficult to resize our array. So we declare count and we read count from the sheet B1, and this tells us the number of students. And then we use this count to create our array at runtime. So again, we'll run this code to our breakpoint, and then we'll look at what we've created in the locals window. So you can see in the locals window, our count is 3. And you can see that we've created an array of size 3, and the slots are of course 0 to 2. So we say count minus 1 because even though there's 3, we know it goes from 0 to 2 rather than 1 to 3. So let's just change it again to give a second example. And I will just replace this with a formula. So in this case, the formula will count the number of students when they're entered on the sheet. So we're just doing a simple count. So when we add some values here, our count gets updated. Now, what this means is that we've changed the number of students, so we've now got 5 students, and our code will still work fine. All we need to do is run our code, and it will run and create an array of the correct size. And remember, we didn't change any lines of code. So we run this again, and when we open our student second array, you can see now we have values 0 to 4, in other words 5 slots. And this didn't require us changing any code. So our code is dynamic, in other words, it can set the size when it is running. So this was a look at declaring the two types of arrays. Now in the next lesson we'll have a look at assigning values to arrays. We're now going to look at assigning values to arrays. Now in the code we have here, you can see that we're not using arrays. So we'll run this code and then we'll go ahead and update it to use arrays so you can see the difference. So it simply reads the values from D3 to D5, places them in a variable and prints out the variable. So we declare our array again by specifying our slots. So we have slots 0 to 2. Now to access any item in an array, we simply use parentheses and the number of the slot. And again, like assigning anything in VBA, to assign a value to it, we place it to the left of an equals, and the value on the right is placed in the value on the left. So to print out the value or to access the value, again, we just use the name of the array and the slot number in parentheses. Now this code will run exactly as the previous code, and you can see that it's not much shorter. But the purpose of this lesson is just to show you how to assign values to individual items in an array. Normally when you use an array, you assign the values in one go, and you do this using a loop and a variable in the parentheses. Now we'll step through this code and we'll just look at our array in the locals window, because this often makes it much clearer what an array looks like. So you can see that the array is simply a number of slots, and in this case it's 3 slots, and we have student 0 and has the value 6, and student 1 has the value 9, and student slot 2 has the value 5. So it's quite similar to using 3 separate variables, except it's just that bit more efficient. Now again, we'll just show an example of reading a value from the array and writing it to a cell. So again, it's just a matter of putting the source on the right hand side of the equals and the destination on the left hand side. And let's just put a value in student slot 0 so that we can see that it updated correctly. So we'll just put an arbitrary value 67. And when we run, we'll get 67 in cell D3. Now in this lesson, we looked at assigning values to arrays. And as I said, normally we'll do this in a loop, but it's very useful to understand what assigning one value at a time looks like. So now let's revisit our previous code and make it more efficient using the loop. So as I said, we normally don't assign values to an array one at a time, and we definitely don't print them out one at a time. We use loops, and this is what makes our arrays so efficient. So let's declare a loop variable I. So we'll start with the printing because this is more straightforward. So we say for I equals 0 to 2, and remember 0 to 2 is the range of our slots. And we just place I in parentheses. So each time it runs through the loop, it'll hit each slot. So we'll display the immediate window and we'll run the code. And we get the values 695. So these are the values from our 3 cells. So we'll put a breakpoint in here and we're going to run again. So let's have a look in the locals window. Now you can see that the value I is currently 0. So the array that we're currently printing out is student in position 0, and we can see the value is 6. So let's highlight this and you see there the value is 6. So student I is 6. So let's move it on. Now the next value we should get is 9 because I now equals 1, and you can see the value at student 1 is 9. And we move it on again, and now I equals 2, and we can see that student 2 is the value 5. So you can see how efficient this is. If our array had 1,000 students, we would just need the same lines of code to print out the values. Whereas when we use variables, we need a line for each one. Now normally when we use an array, we don't specify the slots directly like we did here. We used 0 to 2 here. What we use is L bound and U bound. So you basically say L bound and the name of the array in brackets to U bound. And you can use this on every single array that you use. So what this means is that L bound and U bound are functions that VBA will use to find the lowest bound and the upper bound. So in other words, if we change our array range, instead of 0 to 2, we say it's from 1 to 5, the code will still work perfectly. So we should always use this when using an array. So you see how it brings out the value 695 again. Now let's take a look at the first part of the code. Here we were assigning the values one at a time into student 0. And you can see that this is quite inefficient. So we set D3 to equal student 0, D4 to equal student 1, and so on. So again, if we had 1,000 students, we'd need 1,000 lines. So by using a loop, we can simply get around this. And all we need to change each time is the value in parentheses. Now remember, the value into parentheses is called a subscript. If you ever see the subscript out of range, it means you try to access a subscript that doesn't exist. In other words, if we try to access student 3 here, we'd get a subscript out of range error. So now just before we run, we just need to change the student parentheses as well. So we put I in the student, and we're also using I for the offset. And it reads the values. So what we did here is we use I, and each time it goes through the loop, it moves on one student slot and it moves on one cell using offset. Now let's just change our array, and we're going, instead of 0 to 2, we're going to make it 1 to 3. So we need to update the student to I plus 1, and this is because we've moved our slots from 0 to 2 to 1 to 3. Now when we go to print out this code, it will print out perfectly. And using L bound and U bound in this way simply goes through the range of any array. And this is why it's so useful. So even if we changed our array from 5 to 10 or 15 to 30, it will still print out correctly without changing the code. We're now going to look at passing an array as an argument. So we have the same code as before, except this time we're going to print out our values using a separate sub called print array. So to pass the array here, we simply call print array and then we use student as an argument. Now when we're creating the parameter, we need to specify that it's an array. So what we do is we declare it similar to a normal variable, but we use the parentheses afterwards. So this is just like declaring a dynamic array. And now the sub print array knows that it's receiving an array. Now we've used by ref here, and this is the default. But we cannot use by val for arrays. They must always be passed by ref. And what this means is that if you change the array in the sub, it will be changed when you leave the sub. So it's important to be aware of this. So I've just pasted in the code to print out the values. And when we run the code will work exactly as before. It will print 6, 9 and 5 to the immediate window. So let's go ahead and look at a second example. Now imagine we have a second list of values, and this list of values is team score. So let's have a look at the sheet here, and you can see that we've got a list of team scores in the column G. Now we're going to create a second sub to read these values. So we just need to create our variable, and it's going to be an array of type 0 to 9. And then we just need to change the range that we read from, and this is going to start in column G3. Now we don't need to change the call to our print array. Our print array sub will print out any array of longs. So all we need to do is ensure that we're passing it the correct value. So let's put in a breakpoint so we can check out our array. Now we got an error here because we forgot to change student. So let's just change this student and run it again, and we're at our breakpoint. So now let's have a look in the locals window and see what we've got. So there you can see we've got in all the correct values as we should have. So now we'll go ahead and we'll close the locals window, and then we'll run the code on and see that it prints out the values to the immediate window. Now one thing you'll notice here, that we're calling print array to print out the values, and all we have to do is pass it to the array, and then the print array sub knows how to print out the values correctly. And the reason for this is that the U-bound and L-bound we saw in the last lesson. This gives back the range for any array, so we can pass any array of longs to this sub and it will print out the values correctly. So you can see this makes our code very flexible. Now the one last thing we're going to do is, because this function is going to be used, or this sub I should say, is going to be used by many different subs, we just call array ARR. So in other words, it's not a specific student array or team array, we're just printing out a general array. And this will work the same, but it just makes our code a bit neater and easier to read. In the next lesson, we'll look at passing back an array from a function. Now we're going to look at returning an array from a function. So we have a sub here called readArray, and we want to pass back a new student array that we create. So the first thing we must do is change our sub into a function, because functions can return variables or arrays, etc. Subs cannot return anything. So the first thing we do is change it to a function. Now the second thing we do is specify what we're passing back, and in this case it's an array of long. So we specify this by saying as long and using parentheses. Without parentheses it would mean just one value of long is being passed back, or one variable. So to pass back the value, we assign the name of the function to whatever we want to return, and in this case it's going to be the student array. So you can see here on this line we're passing read array back to student. So we print the values, and here now if we look in the locals window you'll see that student is empty. So we have student here, but it actually has no slots assigned. So in other words, it's an empty array at this point. Now after we run on one line and we've read the value back from read array function, you can see it now as 3 values, and they are 6, 9 and 5. So let's run through this again, and this time we're going to step into the read array function. So we step into the function and you can see that we have a student array. Now this student array has 3 slots assigned to it. So in other words, there's 3 positions here for students, and they're all set to 0 because we haven't placed any values there yet. So now as we step through the loop, we read the values into these 3 positions in our array. Now we're going to assign this array to the return value of our function. So our function is called read array, and by doing this we will return the function. So let's step over this line, and now we can see what's in read array. So this is our return value, and you can see it's exactly the same array of student. So this is the value that's being returned. So we'll step out of this function and we'll have a look in student. So the student array in the original sub now has the 3 values. So in other words, we've passed the values back. And remember, this was empty before the read array line. So we're now going to create a second example. And the second example again is going to read the team scores. So we can see the team scores on the worksheet. And these are the scores in column G. So in this case we've got 10 scores, so our array is of a different size. But as we've seen, we can easily cope with different size arrays. So I've just pasted in the code to read from this array as we've already created it. So we can just copy this code again. And this time we just change the value to read array 2. Now we'll step into the code, and again you'll see that after the student is assigned to the read array and we print out the values, we've printed out the student values. Now the second time we're going to read the team values into student array, and then we print them out and you can see it's printed out the values correctly. So this shows how flexible arrays are. We've got 2 different size arrays, but by using the same pieces of code we can print out the values and we can return the values even though the arrays are of different size. So this provides us great flexibility when dealing with lists of different sizes.